Hello everyone, welcome to Memoneet. I am Aprajita, your chemistry SME. I hope all of you are doing good. So, how is the preparation for the BPT4 going on? So, students, I hope you have completely prepared the first chapter, that is structure of atom, and you have revised the questions also and done the NCRT reading as well. So if you are having any doubts in that particular chapter, you can tell me in the comment section. Okay, I hope you all have watched the video lectures. So there are 3 video lectures for structure of atom where I have discussed all the important concepts of the topic which are important for you to give the Bhramastra part test as well as from the Neet point of view. So the second chapter, you can see for this test we are actually having 2 chapters which are basic chapters but they carry high weightage. So those 2 chapters are structure of atom and chemical bonding and molecular structure. So today I am going to start with chemical bonding and molecular structure. It is a very important chapter, okay, and basic one also, but it carries high weightage. You get a lot of questions from this particular chapter. Okay, so that's what we are going to study today. So if I talk about chemical bonding and molecular structure, what are we going to study in this chapter? So students, till now we have actually studied about atom. How does an atom look like? But you know that matter around us is made up of so many things, so many elements, compounds. So these atoms actually don't exist independently, right? They exist as a group of atoms which are called molecules. Now, to exist as group of atoms, there must be something that is holding them together, no? So what is that thing? What is that force that is holding all the atoms together? So that's what we call as bonding. Okay, so that's what we will be discussing in chemical bonding. So the thing is, students, if I talk about chemical bond, so chemical bond is actually an attractive force that is holding the atoms, molecules, the ions all together, right? So the question is that why do atoms combine? Right? Why do atoms combine? Then the next question is why only certain combinations are possible, why other combinations are not possible, why only atoms combine in certain ratio or in a certain way only, right? So to answer all these questions, we are having different kinds of approaches or concepts that were given by the scientists. Like we had this Causals-Lewis approach. Okay, that was given in the starting. Then we have valence shell electron pair repulsion theory, jisko we call as Vesper theory. Then we have valence bond theory, molecular orbital theory. So all these things will be discussed in this particular chapter. Okay, so let us start with the very basic concepts, that is the chemical bond. So I have told you that chemical bond is actually a force that holds different atoms together in a molecule. Now there are different types of chemical bonds that we are going to study. But before studying the chemical bond, you must know the octet rule, okay? So it was given by Lewis only. So he said that atoms of different elements, they take part in chemical combination in order to complete their octet or to attain the noble gas configuration. Now what does that mean? So you know that the noble gases, they are highly stable because their valence shells are completely filled. Okay, so according to octet rule, the atoms try to become like a noble gas, means it want to have 8 electrons in the outermost shell, which is called as the valence shell. So if there are 8 electrons in the outermost shell, we call it as the octet rule. So by leaving like certain atoms, so we have duplet rule also for K shell. So except K shell, the outermost shell like L, M, N shells, they must have 8 electrons for an atom to be stable. Okay, so atoms, now the question that I asked you na कि why do atoms combine? तो atoms इसलिए combine करते हैं, they do combine to complete their octet or to become stable, because everyone is looking for stability, right? So even atoms are looking for stability. So to become stable and to attain the nearest noble gas configuration, they combine with each other. Okay, so what are valence electrons? They are the outermost shell electrons which take part in the chemical combination. So these are your valence electrons. Now if I talk about the Causals and Lewis theory, students, Actually, various attempts were made by the scientists to study or to tell the chemical bonding in terms of electrons, right? But it was causal and Lewis theory which gave some logical explanation, okay, which was the first one actually to give some logical explanation regarding the chemical bonding, okay. So actually what did causal said? He actually said that in the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by the noble gases. Next point is that the formation of an anion and cation. Anion means your negative ion and cations means the positive ion. So halogens tends to form anions and alkali metals tends to form cations. So he actually said that they are formed by the gain and loss of electrons respectively. Means anion is formed by the gain of electrons and cations are formed by the loss of electrons. Then both the negative and positive ions acquire noble gas configuration. This is important. He said कि both the negative and positive ions will be having noble gas configuration, and these charges, they are stabilized by electrostatic attractions between positive and negative ones. Like for example, you can see sodium. Okay, now sodium has atomic number 11. So in the last lecture I told you how to write the configuration. So it has 11 electrons, neon has 10. So neon 3s1 would be the configuration of sodium. Now you can clearly see कि there is just one more electron. If sodium loses this electron, okay, now it will be having the configuration like that of the neon gas, right? Neon is the nearest noble gas. So here sodium is actually forming a cation. And this sodium cation, Na positive, is having the electronic configuration of a noble gas, right? Then if I talk about chlorine now, so chlorine is having 17 electrons, okay, so its configuration is neon 3s2 3p5. Now do you think is it possible for chlorine to lose 7 electrons to become like neon? No, because removing 7 electrons actually requires a lot of energy. That is not possible. So instead of losing electron, chlorine will gain an electron, all right, and it will form chloride ion which is having a configuration neon 3s2 3p6. Now this neon 3s2 3p6 is the configuration of the another noble gas which is argon. Okay, so this is how the atoms lose or gain electrons. That was suggested by Causal first. Okay, and that thing actually gave an idea about the chemical bonding thing. Okay, this we are discussing the approaches, right? Approaches and the concepts that were given by the scientist. All right. So now what are the different modes of chemical combination? The first one is transfer of electrons. Just we have seen, like you know, sodium will lose electron and chlorine has to gain. Now what if sodium helps chlorine? Like sodium will give its electron to chlorine, okay, and yes, both of them will become stable and they will form a compound called NaCl. So the first way is the transfer of electrons, okay. Means whenever there is a transfer of electrons from one atom to another atom, so that type of bonding or that type of bond which is formed is called the electrovalent bond or the ionic bond, and the bonding is called ionic bonding, okay. But every time it is not possible for the atom to transfer its electron. Like let's say an example of hydrogen has only one electron, okay, 1s1 okay. Now if it wants to form a molecule, so what it will do, if it loses electron, so it's this thing, your H positive will be formed which will not be stable. So in that case what it does, it shares the electron, that we will discuss, okay. So each hydrogen atom will be sharing one electron with each other to form a covalent bond. So basically here there will be no transfer of electron, but there will be mutual sharing of electrons between the atoms. And yes, in these bonds electrons are contributed by both. Okay, like here sodium was giving the electron, chlorine was taking it. But in the case of covalent bonding, both of them will be sharing one, two electrons with each other, okay. Means there will be equal contribution, all right. So these are the two ways of chemical combination, students, but there is one more special type of bonding, special type of covalent bonding I should say. It says it's known as a coordinate bond. So when the electrons are contributed by one atom and shared by both, this is called as a coordinate bond. Okay, let me give you an example, a very easy one in this case that we will be discussing later on. Okay, there is this whole chapter called coordination compounds जो कि based है on coordinate bonding. So let's say I'm having a compound ammonia, it has a lone pair of electrons on it. Okay, and there is H plus. Now H plus is not having any electrons because hydrogen has one electron, and if H it donates its electron, so H plus is having 0 electron. Now H plus wants to become stable. How will it become stable? This nitrogen is having 2 extra electrons. Okay, I will talk about it in later on, like what is lone pair and all of that. So what happens is nitrogen is gonna give both the electrons to hydrogen, not give but share. Okay, so it's kind of a covalent bonding only, कि sharing of electron happens, but the electrons are just provided by only one atom but shared by both of them. So that is going to be known as a coordinate bond. Okay, so this was just an idea. Now let's discuss about the ionic bonding in detail. So I told you it is formed by the complete transfer of electrons from one atom to another, and yes, it is formed between metals and non-metals. This is important because metals are the ones that have a tendency to lose electrons, and non-metals are the ones which have a tendency to gain electrons. Okay, now how these ions are held together. So these ions are held together by electrostatic force of attraction. Okay, so electrostatic force of attraction is holding the ions together, and this type of compound is called the electrovalent or ionic compound. Okay, for example, NaCl we have just discussed. So sodium is 281, chlorine is 287. So if sodium donates one of its electron to chlorine, sodium will form a positive ion that will be stable, and chlorine forms a negative ion that would be stable. So these sodium and chloride ions will be held together by electrostatic forces. Okay, they are not forming any molecule, but they are forming ions which will be held together by electrostatic forces of attraction, and they will be forming a lattice structure. Okay. For example, if I talk about magnesium oxide, so magnesium has a configuration 282 and oxygen has a configuration 2,6. So magnesium is going to lose 2 electrons to oxygen and both of them will become stable. So magnesium will acquire now 2 plus charge. Charge will be equal to the number of electrons lost or gained. So magnesium will have 2 plus charge and oxygen will have 2 minus charge. Okay. Now this charge, whatever we have, we call it as electrovalency. Electrovalency means what is the number of electrons lost or gained during ionic bond formation. Now if I ask you what is the electrovalency of sodium and chlorine, it's 1 each. And what's the electrovalency of magnesium? It's 2. For oxygen, it's also 2. Okay, so that is about the ionic bond. It is formed by the transfer of electrons. Now students, if this is formed by transfer of electrons, there are various factors that are affecting the formation of ionic bond. The very first one is ionization enthalpy. Now what is ionization enthalpy? Firstly, you should know that. Now if you have to remove an electron from sodium, will it remove on its own? No, right? It will be removed when we apply some energy. Okay, energy will be required to remove that loosely bound electron. So what is the ionization enthalpy or energy? It is the amount of energy required to remove an electron from outermost shell of an isolated gaseous atom to convert it into cation. तो hypothetical study के लिए हम बोलते हैं isolated gaseous atom कि अगर मेरे पास एक hypothetical gaseous atom है, उसमें से अगर मुझे इलेक्ट्रॉन रिमूव करना है, so how much energy would be required? Okay, so that is called as ionization enthalpy. Now if you want to make ionic bond, तो you will want कि electron should be removed very easily, right? So electron remove easily कब होगा? जब energy हमें कम देनी पड़ेगी, right? तो it means, this is very important, keep that in mind. It means that lesser the ionization enthalpy, easier will be the formation of a cation. Means जितनी कम energy लगेगी to remove the electron, इतनी easily cation बनेगी, and that will favor ionic bonding. So what is happening in this case, that the Lower ionization enthalpy favors ionic bond. Let me give you an example for that, student. So in the formation of sodium ion, okay, how much energy is required? 496 kilojoule per mole. While if you want to make Mg2 plus from the magnesium ion, okay, how much energy is required? 743 kilojoule per mole. So where the energy is less? In sodium ion formation. So if I ask you कि sodium ion formation would be easier or magnesium ion formation would be easier. So by looking at the value of ionization enthalpy, you will say कि that the formation of positive ion for sodium is easier than that of magnesium. So what you can conclude is lower the ionization enthalpy, greater chances of ionic bond formation are there. Okay. Now if I talk about electron gain enthalpy, so class, it is actually the energy release. अब जब electron add होगा, right? When electron will be added, there would be some energy released. Okay. So if it is defined as the energy release when an isolated gaseous atom takes up an electron to form an ion. ओके तो जितनी ज्यादा अगर इफ इलेक्ट्रॉन इज गेटिंग एडेड ओके इफ इट इज बिकमिंग स्टेबल तो जितनी ज्यादा एनर्जी रिलीज होगी उतनी इजीली एनायन फॉर्मेशन होगी and then it will increase the probability of formation of ionic bond. Okay, for example, halogens. If I talk about halogens, so like your fluorine, chlorine, bromine, iodine, they actually have 7 electrons in their outermost shell. So they just need 1 electron to complete their octet. जैसे ही 1 electron मिलेगा, they will become stable. So they have actually high affinity for the incoming electron. So if they have high affinity for the incoming electron, more energy would be released. Okay, so that is going to favor ionic bonding. So that's why you can say कि formation of anion is very common in halogens. कि जो halogens हैं, they will form anions very readily. Means they can accept the electrons very readily. तो जो affinity है for accepting the electrons, it increases when you go from left to right in the periodic table, and जैसे जैसे आप डाउनवर्ड्स जाते जाएंगे द वैल्यू ऑफ इलेक्ट्रॉन गेन एंथैल्पी विल बिकम लेस नेगेटिव, मतलब कम होती जाएगी. तो एज अ रिजल्ट द you can say tendency to form anion would decrease. Now if I ask you a question ki out of fluorine or iodine, which one will have higher tendency to form anion? So that is going to be fluorine, क्योंकि fluorine is on the top, and when you move downwards the electron gain enthalpy value becomes lesser. So it means the tendency of formation of anion for fluorine is more than the iodine. Okay, next thing is students lattice enthalpy. It is actually one of the important thing about ionic compound. So it is actually defined, it's not related to what we are saying ki formation of ionic compound will depend here. So it's defined as the amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ions. Okay, how much energy will be required if you want to separate the ionic compound to ions? तो actually it depends on two factors, size of the ions. जितना कम size होगा greater will be the lattice energy, and जितना charge, अगर जितना charge ज़्यादा होगा तो उतने ज़्यादा interionic attractions होंगी. Means small size and more charge, तो उतना ही ज़्यादा attraction होगा between the ions, and you will be having higher lattice energy. Means more energy would be required to break that compound. Okay. Now, if I talk about the general characteristics of ionic compound, so see, whenever if I talk about electrostatic force, so ionic compounds में electrostatic force of attraction है, so all these properties are dependent on that only. And this electrostatic force of attraction is a very strong force. So ions are held together by strong forces, so that is why they generally exist as crystalline solids. उनको हम बोलते हैं crystal lattice structure. Okay. So they do not exist as single molecules, I told you, like H2, N2, I2, O2. They are just the ions that are held together, like one sodium ion is surrounded by 6 chloride ions and vice versa. Okay, so that is the thing. Moreover, students, if these are strong forces, so you will have to apply more energy to break that bond. So that is why ionic compounds have high melting and boiling points. Okay. And now these are your ionic compounds. They have ions, so they will be soluble in polar solvents such as water, because you know like dissolves like, so they will be soluble in polar solvents, but they will not dissolve in organic solvents like benzene or carbon tetrachloride, etc. And if I talk about electrical conductivity, so electrical conductivity के लिए what is the condition? That the ions or the charges must be free to move. Okay, so in solid state they will be poor in conductors of electricity. Why? Because these ions are held together at their own place by the strong electrostatic force. They are not free to move in solid state. But if you are having it in molten state, or when you dissolve it in water, the ions are now free to move and they conduct electricity. So if you have to talk about electrical conductivity, ionic compounds conduct electricity in molten state or in aqueous state. Okay. And ionic compounds, they actually produce ions which give very fast reaction with oppositely charged ions. Like हमारे पास if we have sodium chloride, so it will give you sodium ions and chloride ions. So silver nitrate will give you silver ions and nitrate ions. So these ions can interact with each other. Sodium will go with nitrate, this will go with chloride. You will get silver chloride and sodium nitrate. So ionic reactions would be very fast. Okay. Alright, so students, this was about the ionic bond. I hope you have understood everything about the ionic bond. Now the next thing we will be studying are covalent bonds. But before that, let's study about the Lewis symbols. So you know that in the formation of any molecule, क्या सारे electrons participate करते हैं bonding में? No, right? Only the outer shell electrons, they take part in chemical combination. सिर्फ outer shell electrons जो हैं, they take part in chemical combination and they are known as valence electrons. Okay. So inner shell electrons, they are well protected, they are not involved in combination process. For example, if I take the example of sodium only, so 281 is the configuration. So only this outer electron, that is the one valence electron, it will take part in the bonding. These inner electrons will not. Okay. So there was this scientist, there was this chemist, you can say G.N. Lewis. He introduced simple notations to represent valence electrons. Because जब भी हमें bonding represent करनी है, right? Earlier कैसे represent किया जाता था? Like you have sodium, तो one shell में then 2 electrons. Okay, then second shell में 1, 2, 3, 4, then 5, 6, 7, 8 electrons. Then third shell draw करो, then उसमें 1 electron दिखाओ. Okay, then chlorine के ऐसे 3 shells तो फिर bonding दिखाओ. So it's a time consuming process. Okay, so he actually gave us short notations जिसको हम बोलते हैं Lewis symbols. Now what does Lewis symbol says? So Lewis symbol में क्या हुआ? The inner shell electrons and जो आपका inner shell electrons है, they will be denoted by the symbol of the element. Okay, तो symbol लिखेंगे हम and then we will be writing the valence electrons as the dots. तो जितने electrons होंगे उतनी dots. Like if I talk about second period, तो lithium की configuration है 2,1. So I will just write lithium and I will put 1 dot. 1 dot means that it has 1 electron in the valence shell. Similarly, beryllium has 2, 2. Right? So 2 dots. But these dots should be symmetric. Okay. Then boron, 3 dots. Carbon, 4 dots like this. Nitrogen, 5 dots. Okay. Then oxygen, 6 dots. So 1, 2, 3, 4, 5, 6. Symmetric. You have to make it symmetric. Fluorine will be having 7 dots like this. And neon will be having 8 dots because it is having 8 electrons in the valence shell. Now अब sodium की बात करें, so how many dots you will put? Sodium with just 1 dot. Similarly, magnesium with 2 dots. Then aluminium with 3 dots and so on. So this is how we are going to write the Lewis dot symbols. Okay, means just the valence electrons are shown. And that is correct also ना, क्योंकि only valence electrons are involved in bonding, तो inner electrons की हमारे पास जरूरत नहीं है. So why do unnecessarily show them? So this is how we are using the Lewis dot symbol. And class Lewis dot symbols पे questions भी आते हैं NEET exam में. So keep that in mind. So now let's talk about the covalent bonding. So students, this is called the Lewis-Langmuir concept because Langmuir gave us the knowledge about the covalent bond. So you know what is covalent bond. The second approach that I told you, right? The bonds that are formed by the mutual sharing of electrons. Okay. So means whenever the bond is formed between two or more atoms by mutual contribution and sharing of electrons, it's called the covalent bond. Okay. So if you have two similar atoms, let's say H2, N2, O2, so we call it as a homoatomic molecule. If there are different atoms, like if we have HCl, NH3 like that, so we will call it as a heteroatomic molecule. Now you can see here, I told you na ki if I have hydrogen atom, so hydrogen is not going to lose or share electron. Now what they will do is how to write the Lewis structures. Please note here. Firstly, write both the atoms with their your valence electrons. Okay. Then now you have to draw the circle in such a way. Now each hydrogen is sharing one electron. So draw this structure. Now this structure represents that this circle there are two electrons for this hydrogen, and here we have two electrons for this hydrogen. Okay. So it means how many electrons are shared in total? Two. Means one electron by each atom. So this is known as a single covalent bond. Single covalent bond is formed when each atom shares one electron. But कभी कभी one electron share करने से काम नहीं चलेगा, right? So in that case, more than one electrons are shared for oxygen. Now what is the configuration of oxygen? 2,6. Oxygen needs 2 electrons to become stable, right? So I will draw 6 electrons that oxygen has in the valence shell, this oxygen atom also. Now it will be sharing 2 electrons, not just one, because one share करने से 7 होगा, octet would not be complete. So 2 electrons would be required. So it will be sharing 2 electrons like this and this atom like this. So how many electrons are shared? You can see total 4 electrons are shared. So we'll represent this molecule by two dashes. Each dash represents 2 electrons. So this kind of a bond which is formed by sharing of 2 electrons each by atom. So it's called a double covalent bond. Now you see you can have different types of atoms also heteroatomic, like for water. Water ke case mein you have oxygen having 6 electrons. So this is hydrogen and this is hydrogen. Now oxygen will be getting 1 electron each from the hydrogen atoms to complete the octet, and hydrogen jo hai it will be sharing 1 electron with the oxygen. Okay, like this, one here, one here. So you will get 2 single bonds in this case. Similarly for ammonia. Now I will tell you what is this lone pair thing now. Now nitrogen has 5 electrons in the valence shell, right? 2, 5. So 1, 2, 3, 4, 5. Now ammonia is NH3. So one hydrogen and one hydrogen. Now ammonia needs 3 more electrons. तो इसलिए वो 3 हाइड्रोजन के साथ combine कर रहा है. So you will get here like this. यहाँ पर हमने हाइड्रोजन का duplet complete कर दिया. And now for nitrogen, see here. Now you see कि 3 electrons तो bonding में participate कर रहे हैं like this. 3 bonds बन रहे हैं. 3 single bonds are formed. But these 2 electrons, can you see they are not participating in any bonding, but still they are present in the valence shell. So हम इसको represent करेंगे by 2 dots. So these kind of atoms, these kind of electron students that are not participating in bond formation are known as lone pair of electrons. Okay, इनको हम बोलेंगे lone pair of electrons. Okay, like I told you that one electron pair is shared. So if one electron pair is shared, we get a single covalent bond. If two are shared, we have double covalent bond. Can you see here? In carbon dioxide, students, there is a formation of 2 double bonds. Okay, like here you can see carbon has actually 4 electrons only. Okay. So with oxygen, it will be sharing 2 electrons from one side because it needs 4 now, and 2 from other side. These I have drawn 6 electrons for oxygen. तो यहाँ से carbon will be getting 2 from this oxygen, 2 from this oxygen, and उसके 8 complete हो जाएंगे. And oxygen also requires 2, तो इतना यहाँ पर 2 share होंगे, यहाँ पर 2. So this is how we'll be drawing the Lewis dot diagram for CO2. तो कितने कितने electrons share हो रहे हैं यहाँ पर? 2, 2 each. So where there will be a double bond. दिस इज द स्ट्रक्चर ऑफ CO2. सिमिलरली जो हमारे ऑर्गेनिक कंपाउंड्स होते हैं लाइक हियर इन C2H4 विच इज इथीन. इथीन में भी डबल बॉन्ड फॉर्मेशन है बिटवीन द टू कार्बन atoms. You can see the Lewis dot diagram in this case. So carbon has 4 electrons. one यहाँ से it will be taking from hydrogen and 2 it will be taking from another carbon. तो total होगा 8, right? Similarly for this carbon also total will be 8. But now I told you कि if 3 pair of electrons are shared, 2 तो हो गए, right? अगर 3 share होंगे तो in the case of nitrogen only, like nitrogen is 2,5, how much it requires? 3 more. अगर ये दूसरे nitrogen के साथ combine कर रहा है, so how many electrons it needs? 3. So it will be taking 3 electrons from the other nitrogen like this and here like this. So how many electron are shared? 3 electron pairs are shared. तो जब भी 3 electron बनेंगे we'll show triple line with the lone pairs also, and this is your nitrogen molecule which has a triple covalent bond. Okay, so you see 3 type के covalent bond होंगे, single, double and triple. Like in ethyne molecule also C2H2 में भी, okay, C2H2 molecule में भी there is a triple bond between the carbon atom. All right. So how can we represent the Lewis dot symbols or Lewis structures for some simple molecules? So it is actually providing us a picture of bonding कि कैसे bonding हो रही है, right, in terms of shared pair of electrons and octet rule. So we are not getting everything, we are not getting to know everything about the molecule completely, but we get to know ki how the molecule is being formed, right? How the sharing is happening in this case. So how to write the Lewis dot structures? Like if they give you any random molecule, so what you will do in first case? Firstly, you will see कि how many valence electrons are there. कि उस Lewis, अब you know कि Lewis dot structure में we will just show valence electron. So just calculate the valence electrons for both the atoms. जितने भी atoms उसमें दिया उनको add कर दो. For example, हमें लिखना है Lewis dot diagram of CH4. तो कार्बन के कितने वैलेंस इलेक्ट्रॉन्स हैं? 4. और एक हाइड्रोजन के पास कितना है? 1. तो 4 into 1, तो टोटल कितने हो गए? 8 वैलेंस. तो मीन्स जब भी आप ये स्ट्रक्चर ड्रॉ करेंगे यू नीड टू शो कि देयर आर 8 वैलेंस इलेक्ट्रॉन्स, ओके, जो बॉन्डिंग के लिए अवेलेबल है, राइट? 8 वैलेंस इलेक्ट्रॉन्स आर देयर फॉर बॉन्डिंग. Now for anions, अब अगर कोई anion है साथ में, तो if there is a negative charge means you need to add 1 electron, and if there is a positive charge you need to subtract 1 electron. For example, CO3 2 negative, okay, so 2 minus charge means if I calculate the valence electrons, चलो करते हैं, 4 for carbon and oxygen के पास कितने होते हैं? 6, right? So 3 into 6 is 18. कितने हो गए total? 22. But there is 2 minus charge, मतलब 2 electrons इसके पास extra है. Negative charge means it has gained. So total electrons जो आप bonding के लिए यहाँ पर show करेंगे that will be 24. Okay. Similarly for NH4 positive, अगर मैं nitrogen की बात करूँ, total 5 electrons and 4 hydrogen के total 4. तो how many electrons? 9. But there is a positive charge. Positive charge means 1 electron will be removed. So you have to show total 8 electrons. Okay, so this is how we will be writing the symbols. So now अभी इसके लिए हमें chemical symbols पता होने चाहिए, and if we know the skeletal structure, so हम उसको guess भी कर सकते हैं, like कि straight होगा या like जैसे carbon dioxide था, we have got an idea कि there will be 2 oxygen on both the sides, right? So we can distribute the number of electrons between the atoms. And if you have like atoms of different electronegativity, so the one that is least electronegative gets the central position. For example, NF3 है आपके पास, right? If you have NF3, so which one is less electronegative? Of course nitrogen. तो nitrogen less electronegative रहेगा, वो center में रहेगा, and fluorine will have terminal position. Similarly, CO3 2 negative में carbon will be having a central position and oxygen will be having terminal position क्योंकि carbon is less electronegative. Okay. So again the basic requirement is कि हर atom का octet complete होना चाहिए. Like you can see here we have shown the bonding for hydrogen, यहाँ पर oxygen के लिए. For O3 molecule we have shown NF3. For carbonate ion like CO3 2 negative, I told you na how many electrons would be there, 24 electrons. So can you count here? I am having 24 electrons only. 1 2 3 4 5 7 8. Okay, 1 2 3 4 5 6 7 8. 8 plus 8 16 and 8 here 24. So you can see that this is how we are going to show the structures. Like for HNO3 also we have shown in this case. Alright students, so this is how we will be writing the Lewis dot symbols or Lewis representations for different structures. Okay. Now students, here you can see that in some structures we are having some positive and negative charges, right? Here plus minus is there in this also, like on a particular atom, not as a whole but on a particular atom. Now this Lewis dot structures does not talk about the shape of the molecules, right? So actually if we are having charges as a whole, so we can also tell the charge on a particular atom, and that will be known as formal charge. Okay, so in polyatomic ions, net charge means the charge on the ion as whole, like CO3 2 minus. So here this 2 minus is a net charge. Okay, it doesn't mean that it is on a particular atom, it's on the carbonate ion as a whole. Okay, but charges can be assigned to individual atoms or ions as well, and we call them as formal charge. Now what is the formula for calculating formal charge? This is also important from Neet point of view. Okay, so it is actually equal to total number of valence electrons in the free atom. Okay, minus, like for a particular atom, for each atom you have to calculate now, then total number of non-bonding electrons. I told you non-bonding electrons are called the lone pair of electrons, minus half of the total number of bonding electrons. Very easy formula. Okay, so total number of valence electrons minus the total number of you can say non-bonding electrons minus half of the total number of bonding electrons. That will give you the formal charge on the atom. It is not a real charge, okay students, but it's just we are calculating it. So like for ozone, now ozone structure, so there is a double bond between two oxygen like this. All right, so 1 2 3 4, because 6 electrons are there now for oxygen, तो यहाँ पर 2 are shared only. यहाँ पर out of 2, 2 here and 1 here, like 2 here are shared, so it's 1 2 3 4 5 6. Okay, so this is 1 2 and 3. This is the structure for ozone. Now let's calculate the formal charge for oxygen 1. Now for oxygen 1, total number of valence electrons on oxygen we know it's 6. How many non-bonding electrons are there? 2. Okay, it's actually a coordinate bond that will be formed here, because you can see कि यहाँ पर 6 के 6 electrons present हैं, तो 2 यहाँ share हो रहे हैं इस oxygen के और 2 यहाँ पर, 4 share हो गए और 2 ये रहे. तो how many lone pair of electrons, like how many non-bonding electrons? 2. एंड हाउ मेनी बॉन्डिंग इलेक्ट्रॉन्स, उसका हाफ करेंगे तो बॉन्डिंग इलेक्ट्रॉन्स कैसे निकालेंगे? देखो 1 यहाँ पर, 2 यहाँ पर, 3 4 ओके 5 6, क्योंकि ये भी तो शेयर्ड है ना, राइट? 6 आर शेयर्ड एंड 2 आर इन लोन पेयर, तो यहाँ पर लिखेंगे 6. सो कितना हो जाएगा ये? 6 माइनस 2 माइनस 3 विच इज 6 माइनस 5 विच इज 1. तो यहाँ पर इस ऑक्सीजन पर आपका +1 चार्ज आ जाएगा. ओके, एंड यहाँ पर आएगा आपका माइनस चार्ज, क्योंकि अगर हम थर्ड उस पर निकालें सो द वैल्यू इज -1, सो इसलिए माइनस चार्ज, एंड सेकेंड ऑक्सीजन पर 0. सो दिस इज हाउ सिमिलरली वी कैन कैलकुलेट. सो यहाँ पर देखो एक ऑक्सीजन पे प्लस चार्ज है, एक पर माइनस चार्ज. ओके, सो दिस इज हाउ वी कैन कैलकुलेट द फॉर्मल चार्जेस. तो हम यहाँ पर ऐसे रिप्रेजेंट कर सकते हैं ऑफ फॉर द ओजोन मॉलिक्यूल. 1 ऑक्सीजन विद अ पॉजिटिव चार्ज, 1 विद अ नेगेटिव चार्ज. ओके, now let us talk about the limitations of octet rule. अब जो octet rule है, yes it is useful but it's not universal, means it's not valid for all the type of molecules. तभी हम आगे और theories पढ़ेंगे, right? So actually it is useful for understanding structure of most of the organic compounds and second period elements के लिए, but there are three type of exceptions. Okay, now what are the exceptions? The incomplete octet of central atom in some compounds. Like क्या होता है, suppose you are having a molecule, so उसमें आपको दिखेगा कि the number of electrons that are in the central atom is less than 8. Still that molecule exists. Okay, और स्पेशली ये उन एलिमेंट्स में होते हैं जिनके पास लेस देन 4 वैलेंस इलेक्ट्रॉन्स है, लाइक लिथियम क्लोराइड. अभी लिथियम क्लोराइड में क्या हो रहा है? नाउ लिथियम हैज 2,1 कॉन्फ़िगरेशन एंड क्लोरीन हैज 287, है ना. तो 1 इलेक्ट्रॉन शेयर हो रहा है एंड यू विल गेट दिस. बट लिथियम का यहाँ पर जो ऑक्टेट है लाइक 2 हो जाएगा ये, बट इट इज नॉट गेटिंग कंप्लीटेड, राइट. बेरिलियम हाइड्राइड में भी ये होगा. BCl3 में बोरोन के पास 6 इलेक्ट्रॉन्स हैं, यहाँ बेरिलियम के पास 4 हैं, यहाँ 2 हैं, तो 2 4 6. तो these are not octet, right? But still these molecules exist. So यहाँ पर आप देख सकते हो, right? तो here the octet is not getting completed. Similarly, aluminium chloride BF3 में भी the central atom is not having a complete octet. Okay, now if you have odd number of electrons, like nitric oxide में you have 5 electrons from nitrogen and 6 from oxygen, तो total कितने हो गए? 11. Okay, similarly nitrogen dioxide में 5 plus 12 कितने हो गए? 17. So यहाँ पर भी octet rule is not satisfied for all the atoms. Like you can see the structure of nitric oxide. So यहाँ पर नाइट्रोजन के ओनली 7 इलेक्ट्रॉन्स कंप्लीट हैं, राइट. सो इट्स ऑक्टेट इज नॉट गेटिंग कंप्लीट इन दिस. 1 2 3 4 1 2 3 4 5 6 7 7 ही तो इलेक्ट्रॉन्स हैं, राइट, यहाँ पर. सो अगेन यहाँ पर जो है ऑक्टेट रूल इज नॉट गेटिंग ओबेड. Okay, now you know कि in expanded octet, the third point is expanded octet. Okay, 3 points आ रहे हैं यहाँ पर. Incomplete octet, then odd number of electrons, odd electrons molecules and expanded octet. अब जो elements हैं class that are beyond the third period of periodic table, apart from 3s and 3p, उनके पास 3d orbitals होते हैं. And whenever any element is having 3d orbital which is empty, so that 3d orbital is available for bonding. तो जो आपका element है, it can expand its octet, okay, and the electrons can go to the ऑर्बिटल. तो वहां पर मोर देन 8 वैलेंस इलेक्ट्रॉन्स हो जाते हैं अराउंड द सेंट्रल एटम. ओके, विच वी कॉल एज एक्सपेंडेड ऑक्टेट. सो अगेन ऑक्टेट रूल इज नॉट अप्लाइड इन दिस केस. फॉर एग्जाम्पल PF5. सो यहाँ पर PF5 में देखना फॉस्फोरस के 5 इलेक्ट्रॉन्स ऑलरेडी हैं, राइट, एंड 5 वो फ्लोरीन के साथ शेयर कर रहा है, लाइक 1 2 3 4 5 6 7 8 9 10. तो यहाँ पर टोटल 10 इलेक्ट्रॉन्स है अराउंड फॉस्फोरस, मोर देन 8. वाई? बिकॉज फॉस्फोरस हैज दिस एम्प्टी 3d ऑर्बिटल. सिमिलरली SF6 में यू हैव 12 इलेक्ट्रॉन्स. सी 8 से कितने ज्यादा है. एंड हियर ऑल्सो सल्फर has 12 electrons in H2SO4 because of the empty 3d orbitals. तो octet जो है वो expand हो जाता है and that's how the octet rule is not applicable in this case. Okay, now what are the other drawbacks? Like some other drawbacks are कि octet rule is based upon the inertness of noble gases. Octet rule है इस base पर कि noble gases have a complete octet and other atoms try to become like their nearest noble gas. But you know कि there are some exceptions like xenon and krypton. They actually combine with oxygen and fluorine to form some compounds. So this octet rule cannot explain कि how these noble gases are forming compounds. Next thing is this theory does not account for shape of molecules. So from this theory we cannot get any idea about the shape of the molecules, and it does not tell about the stability of the molecules. If it is not telling stability, means it is totally silent about the energy of the molecule. We don't get to know whether the molecule would be stable or not, okay, and what is the energy, high energy, low energy, right, like that. So these are some of the limitations of the octet theory. So students, we have actually discussed about the different types of bonding, okay, then we discussed the octet rule as well. Now we need to see कि what are the different bond parameters. Okay, like what are the things, suppose you are having this particular bond, so for this bond I'll be having different bond parameters that will let me know about the stability, shape and everything about the molecule. So what are those bond parameters? Let's see. The first one is bond length. Now bond length is actually the equilibrium distance between the centers of nuclei of two bonded atoms. Okay, and it can be experimentally defined by X-ray diffraction, electron diffraction method that you will learn in higher classes. Now here let's see, this Ra and Rb are the covalent radii of atoms A and B. Okay, so they are in close contact with each other. So जो bond length होगी R or A, it will be represented by Ra plus Rb. So this bond length will be this much. Okay, means the equilibrium distance between the center of nuclei of two bonded atoms. तो वो आपकी क्या हो जाएगी? Bond length. Okay, bond length, bond angle, they actually play a major role in determining the stability, shapes of the molecule. So you must know कि सबसे पहले what is bond length, what is bond angle also. Okay. Now what is bond angle? It is defined as the angle between the lines representing the orbitals containing the bonding electrons. Let's say if I am having this H2O molecule like this, so bond angle means what is the angle between these two lines. Okay, यहाँ पर इन दोनों लाइंस के बीच में जो कि हमें बॉन्डिंग इलेक्ट्रॉन्स दिखा रही है, इसके बीच में क्या एंगल रहेगा, सो दैट विल बी नोन एज बॉन्ड एंगल. तो बॉन्ड एंगल इज वेरी इंपॉर्टेंट टू डिटरमिन द शेप ऑफ द मॉलिक्यूल. ओके, so degrees may be represented and it can be determined by spectroscopic method. Spectroscopy se we can determine the bond angle. Now bond enthalpy, this is important. It is actually defined as the amount of energy required to break 1 mole of bond of particular type and to break them in gaseous atom. ओके कि कितनी एनर्जी लगेगी उस बॉन्ड को तोड़ने के लिए, दैट विल बी नोन एज बॉन्ड एंथैल्पी. तो जो बॉन्ड एंथैल्पी है डिपेंड्स ऑन द बॉन्ड लेंथ. ओके, बॉन्ड लेंथ एंड बॉन्ड मल्टीप्लिसिटी पे भी डिपेंड करता है. सो फर्स्ट ऑफ ऑल यूनिट्स क्या रहेंगे? बॉन्ड डिसोसिएशन एंथैल्पी. इसको बॉन्ड डिसोसिएशन एंथैल्पी भी कहते हैं और सिंपली बॉन्ड एंथैल्पी बिकॉज वी आर डिसोसिएटिंग द बॉन्ड. सो द यूनिट्स आर किलो जूल पर मोल. जितनी ज्यादा बॉन्ड एंथैल्पी होगी उतना ही स्ट्रॉन्ग बॉन्ड होगा, राइट? लाइक फॉर हाइड्रोजन हाइड्रोजन बॉन्ड द बॉन्ड एंथैल्पी इज 435.8 किलो जूल पर मोल. ओके, so obviously if a strong bond is there, more energy would be required to break that bond, no? And जो magnitude है bond enthalpy का, it is dependent on bond multiplicity also. Okay, जितनी ज्यादा bond multiplicity होगी उतनी short वे आपकी bond length हो जाएगी and more will be bond enthalpy. For example, you know कि जो triple bond होंगे, right? Let's say carbon carbon triple bond, double bond, single bond. तो सबसे ज्यादा strength जो होगी वो carbon carbon triple bond की होगी. Okay, and it will be having highest bond enthalpy followed by double bond followed by single bond. Okay, यहाँ पे एग्जाम्पल दिया, कार्बन कार्बन सिंगल बॉन्ड की बॉन्ड एंथैल्पी इज 347 किलो जूल पर मोल एंड फॉर डबल बॉन्ड इट्स 610. सी ऑलमोस्ट डबल. सो दैट गिव्स अस द आइडिया अबाउट द स्ट्रेंथ ऑफ द बॉन्ड एज वेल. Now if you have polyatomic molecules, so उस case में we cannot tell a single bond enthalpy. Like for H2O ना, H2O में there are two bonds, so for that we need to give the average bond enthalpy. तो जब first bond टूटेगा, right, so the energy is 502. If the next one will break, it's 427. Because of the environmental conditions the bond enthalpy changes. So in that case we will find the average bond enthalpy. So average bond enthalpy क्या होगी? The sum of both of these divided by 2. Okay, ऐसे average निकालते हैं ना, right? So it will come out to be 464.5 kilojoule per mole. So that's how we calculate the average bond enthalpy for polyatomic molecules. Okay. Next thing is students bond order. Now what is bond order? According to Lewis, in a covalent bond order means how many number of bonds are there. Like for H2, I have one covalent bond, na? So bond order is 1. For O2, I have 2 bonds, so bond order will be 2. Similarly for nitrogen, it's 3. It can also be in decimals. We will see how in later concepts. Okay. And isoelectronic molecules have identical bond order. Isoelectronic molecules means which have same number of electrons. Okay, so they will be having same bond order, like for F2 and O2 2 minus. Okay, they will have a bond order 1. Similarly N2, CO, NO plus, they have a bond order 3. ओके क्योंकि यहाँ पर 14 इलेक्ट्रॉन्स रहेंगे दोनों केस में, बॉन्ड ऑर्डर 3 रहेगा. ऑल राइट. एंड आई टोल्ड यू कि जितना ज्यादा बॉन्ड ऑर्डर होगा द बॉन्ड एंथैल्पी इंक्रीजेस एंड बॉन्ड लेंथ डिक्रीजेस. ओके, लाइक हियर यू सी ट्रिपल बॉन्ड के केस में द बॉन्ड एंथैल्पी वुड बी द हाईएस्ट एंड बॉन्ड लेंथ इज लेस. तो यहाँ से यू गेट टू नो स्टूडेंट्स कि द बॉन्ड एंथैल्पी, दिस इज वेरी इंपॉर्टेंट, प्लीज नोट, इट इज डायरेक्टली प्रोपोर्शनल टू द बॉन्ड ऑर्डर. ओके, एंड इट इज इनवर्सली प्रोपोर्शनल टू द बॉन्ड लेंथ. क्योंकि इसके बेसिस पर एप्लीकेशन बेस्ड क्वेश्चंस पूछे जाते हैं इन द नीट एग्जामिनेशन, सो दैट यू मस्ट नो कि इट इज डायरेक्टली प्रोपोर्शनल टू द बॉन्ड ऑर्डर एंड इनवर्सली प्रोपोर्शनल टू द बॉन्ड length. Okay. Now students, let us talk about another important concept of chemical bonding, that is resonance structures. So actually it is often observed that a single Lewis structure is inadequate for the representation of molecule in conformity with its experimentally determined parameters. Now I'll explain what does that means. So here we have an ozone molecule. Okay, now this ozone molecule can be represented by 3 structures. I told you now that there is a double bond between 2 oxygen and then single bond. But how do we know ki where this double bond is? Is it between 1 and 2 oxygen or 1 and 3 oxygen? Okay, so we can say it can be between 1 and 2 also, and it can be between 1 and 3 oxygen also. Okay, so these are the resonance structures for the ozone. Now what I'll tell you, now you see here the bond length. Now actually the bond length of an oxygen-oxygen single bond is 148 picometer. Picometer is 10 to the power minus 12 meter. Okay, and the bond length for oxygen-oxygen double bond is 121 picometer. But when it is found out that in the case of ozone molecule, what is the bond length? So it should be like this only, na, ki one bond is having 148 picometer and another bond is 121. But it is found out that the bond length are same. Yes, bond lengths are same, means the ozone molecule, the bond length is 128 picometer, which is between 148 and 121. It means that these bonds have a partial double bond character, means somewhere between a single bond and a double bond. So this thing cannot be represented by either of the two Lewis structures. Okay, because यहाँ पर तो bond length would be different, but bond length is 128. Okay, so then only this concept of resonance was introduced to deal with such type of molecules. Okay, so whenever a single Lewis structure cannot describe a molecule accurately, what happens is a number of structures with similar energy, positions of nuclei, bonding and non-bonding electron are taken as canonical structures. Okay, so these two structures that we have taken for ozone are the canonical structures. Okay, these are your canonical structures for ozone, and this is the resonance hybrid. Okay, so we will be calling it as the resonance hybrid of the ozone molecule. Okay, means the third structure, the resonance hybrid, represents the structure of oxygen more accurately. Okay, so this is what resonance is. Now if I talk about the polarity of bonds, so there are two type of covalent bonds, polar and non-polar. So you know that no bond is 100% ionic or 100% covalent. So covalent bonds have some ionic character and ionic bonds have some covalent character. So what are non-polar bonds? So whenever we have atomic molecules, right, like H2, O2, Cl2, so both the atoms have equal electron activities, means they have equal tendency to attract the shared pair of electron. So the shared pair of electron will be equally attracted by the atoms. In that case we call it as a non-polar covalent molecule or covalent bond. But here the electron will be lying in the center of the bonding atoms. Okay, because no poles are developed, means no positive or negative. That's why it is known as a non-polar molecule, like H2, Cl2. But again, polar bonds will be the ones whenever we have different atoms. Like if I have HCl, and we know that chlorine is more electronegative than hydrogen. So obviously the shared pair of electron will be more towards the chlorine atom, like this. So chlorine will develop a partial negative charge. Okay, we represent it like this. This is partial negative, and hydrogen will have a partial positive charge. Okay, so this bond will be known as a polar covalent bond, students. Like in H2O also, oxygen is more electronegative than hydrogen. So the shared pair of electron lie closer towards oxygen. So oxygen will have a partial negative charge and hydrogens will have a partial positive charge. Now there are poles developed, right? Positive and negative poles. So that is why we call them as polar molecules. Now this polarity leads to something which we call as dipole moment. So dipole moment is polar molecules को हम dipole molecules भी कहते हैं, and they have dipole moment. So dipole moment, what is it? It is the product of magnitude of positive and negative charge and distance between the charges. कि कितना charge है into distance of separation, and इसको हम represent करते हैं in debye units, capital D. And 1 debye is 3.33564 into 10 to the power minus 30 centimeter. Okay. Now class, ये जो dipole moment है, it's a vector quantity, means you represent it by arrow with a tail on the positive head and head pointing towards the negative center. Okay. Means in HF molecule, fluorine will be electron like partial negative, hydrogen will be partial positive. So electron density कहाँ shift हो रही है? Towards chlorine. So this arrow will represent the shift in electron density with this end. Okay, so here you have to show this end also. Okay. So with the help of dipole moment, degree of polarity can be expressed. Now if I talk about polyatomic molecules like H2O, it has a bent structure. So यहाँ पर जो दोनों bonds है, they are oriented at this angle 104.50 degrees. तो नेट डाइपोल मोमेंट यहाँ पर हम निकालते हैं, वी फाइंड आउट द रिजल्टेंट. सो यहाँ पर आप देखो कि दोनों तरफ ही जो डाइपोल है, इट इज पॉइंटिंग टुवर्ड्स द ऑक्सीजन, राइट, इट इज पॉइंटिंग टुवर्ड्स ऑक्सीजन. तो यहाँ पर हम रिजल्टेंट डाइपोल निकालेंगे एंड द वैल्यू विल कम आउट टू बी 6.17 into 10 to the power minus 30 coulomb centimeter. Okay, it's not centimeter, it's coulomb into meter, because charge into distance ना, so coulomb into meter. Now you know, ऐसा नहीं है कि if there is dipole moment, so a molecule as a whole will be polar. Now for example, in the case of BeF2, BeF2 के केस में students, the direction of the dipole is opposite, right? Because it will be pointing towards the fluorine यहाँ पर, and here it will be pointing towards the fluorine. So as a result they will cancel each other. एक दूसरे का effect cancel हो जाएगा and जो net dipole moment है वो क्या हो जाएगा? 0. Okay, so the molecule will become non-polar. So dipole moment is an important topic. Questions are asked in your Neet exam from here. Okay, like if I talk about tetraatomic molecule BF3, ये यहाँ पर भी जो dipole moment है वो 0 है. Why? Because BF3 में जो bonds हैं, they are oriented at an angle of 120. Okay, तो as a result जब हम इसका net dipole moment निकालते हैं, it will cancel each other because it's in opposite direction again. So if these are in opposite direction, if we calculate the net dipole moment, it will come out to be 0. So ये आपको पता होना चाहिए. Okay, like it is 0 in the case of BF3. Now students, let me tell you an interesting fact. Okay, इसके ऊपर बहुत बार question आ चुका है on NEET examination many a times, that is on the dipole moment of ammonia and NF3. Now this ammonia and NF3, both the molecules have pyramidal shape, okay, with a lone pair of electron on nitrogen atom. दोनों ही case में there is a lone pair of electron. Now you know कि fluorine is more electronegative than nitrogen. Okay, the resultant dipole moment of ammonia is greater than that of NF3. So I told you that a fluorine is more electronegative than a hydrogen. So it means कि जो dipole moment है वो NF3 का ज़्यादा होना चाहिए than NH3. But in experimental results, it's found out that the dipole moment of ammonia is actually more than NF3. So that's why this makes it an important question. Now why it happens? Because in the case of ammonia, the orbital dipole due to the lone pair is in the same direction as resultant dipole moment. So as you can see here students, that hydrogen और nitrogen में nitrogen is more electronegative. So dipole इस direction में रहेंगे and resultant dipole भी इसी direction में होगा. And this resultant dipole and the dipole due to the lone pair are in same direction. So they add up. यहाँ पर add हो जाएगा. But in the case of NF3, the dipole of this NF bond is in opposite direction. And the dipole of this lone pair is in opposite direction. So as a result, this will be getting subtracted. If we want to calculate the net dipole moment, तो वो subtract करके निकलेगा. So that is why in this case, ammonia will be having more dipole moment than NF3. So this is an important case, okay. So students, just like we saw in the case of covalent compound that they have ionic character, means polarity is there. Similarly, the ionic compounds also have some covalent character that is told to us by Fazan's rule. Okay, ionic bonds also have a partial covalent character. So he actually says smaller the size of cation, larger the size of anion, greater is the covalent character. कि जितना cation का size कम and anion का size ज़्यादा होगा, greater will be the covalent character. This is the first point. And the second point is greater the charge on cation. मतलब cation should have small size and more charge. Okay. So जितना ज़्यादा cation पर charge होगा, greater will be the covalent character. But if you have cations of same size and charge, so the one will which is having electronic configuration of n-1d, okay, typical of transition metals, वो ज़्यादा polarizing होगा than a noble gas configuration. Okay, so cation actually polarizes the anion, pulling the electronic charge towards itself and increases the covalent character. Okay. So that is the thing, and the polarizing power of cation and the polarizability कि कितना आपके anion polarize हो सकती है, that are the two factors which determine the percentage covalent character of ionic bond. That you will also learn in other chapters. This is just an idea about the covalent character of ionic bonds. Okay. So students, with that we have discussed many topics of this chapter, chemical bonding. So now after that we will be discussing the valence shell electron pair repulsion theory, molecular orbital theory and valence bond theory. But that we will be doing in the next session. So if you are having any doubts in this particular class, please do let me know. Okay. So you can use the comment section and please join our Telegram channel. There we will post interesting things, interesting quizzes. So you can join that from our group description. So thank you so much students. We will meet in the next session. Until then, bye-bye.